We want to continue working with rational expressions, and in this video, we want to look at writing them in lowest terms. If you think about working with fractions, we divided out the common factors. So we said 4 is 2 times 2, 12, 2 times 2 times 3. We took out all of the common factors and simplify that fraction to 1 over 3. We're going to do the same thing with our rational expressions. So the first step, one that people often forget, is to completely factor the numerator and the denominator. Next, we divide out any common factors. And we're going to, even though Pearson doesn't ask this, we're going to find restrictions for the expression, just so that you have some practice with that as we continue through working with rational expressions. So step one, we're supposed to completely factor the numerator and the denominator. I can see that -2 is common in the numerator. If I divide each term by -2, I have -2 times x plus 3 and x plus 3 in the denominator. Now, this is what you should not do. Do not look at this and say, oh, the 3's are common and the x's are common. No, 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 no. We're supposed to divide out common factors. Remember that factors multiply each other. We could write in the denominator that this is 1 times x plus 3. This is -2 times x plus 3. We see that x plus 3 is our common factor. And this simplifies to -2 over 1, or just -2. When we're looking at our restrictions, we're looking at the denominator. X plus 3 cannot equal 0. So we see that x cannot equal -3. I hope question 2 is fairly straightforward. You should know that when we're adding, order doesn't matter, and we can write this as x squared plus 5 over x squared plus 5. Again, even though there are not brackets written here, we understand that together they are a factor, and they divide out to equal 1. When we're looking at the restrictions, we know that x5 plus x squared cannot equal 0. That means that x squared cannot equal -5. Well, like we said in the last video lecture, x squared is never going to equal -5 if x is a real number. This tells me that there are no restrictions for this expression. I do want to point out that when we're looking for restrictions, we start with our original expression. So even though once we've simplified, there is no denominator in either of these, we still check back to the beginning when we're looking for restrictions. Now, question 3 is interesting, and it shows up quite often. These are not the same numerator and denominator. We can see in the numerator that x is positive, but in the denominator, x is negative. In the denominator, 5 is positive, and in the numerator, 5 is negative. So they're not the same. In fact, we say that these are opposite factors. Each term is the opposite of the same term in the bottom. So if x is positive on top, x is negative on the bottom. If 5 is negative on top, 5 is negative on the bottom. And in fact, I could divide -1 out of the denominator. 5 divided by -1 is -5, and negative x divided by -1 is positive x. Now I have common factors here. I could rewrite that denominator as -1 times x minus 5. The x is positive and the 5 is negative. We see now that we have common factors. And this simplifies to 1 over -1, or simply -1. In fact, whenever we have opposite factors, we can divide them out knowing that it will equal -1. Look at the example in question 4. In brackets, we have opposite factors, 4x minus 1 and 1 minus 4x. The 4x is positive on top and negative on the bottom. The 1 is negative on top and positive on the bottom. Because these are opposite factors, we can divide them out and know that that equals -1. Our simplified expression then is -3 over x, or we could write this as the negative of 3 over x. Either of those is fine. Now we didn't check for restrictions, so let's go back to question 3. The denominator cannot equal 0. So if I add 5 to both sides, add x to both sides, I see that x cannot equal 5. What about our denominator in question 4? The denominator cannot equal 0. Well, this is already in factored form. Remember that we know that x cannot equal 0 and 1 minus 4x cannot equal 0. Subtract 1 from both sides, divide by -4. X cannot equal 1 over 4. I want to be clear about a couple of things. If you're only being asked to simplify, then this is our expression in simplified form for question 3. These are our expressions in simplified form for question 4. Over here, we have our restrictions. You may not always be asked for restrictions. Pause your video for questions 5 and 6. I would like you to write these in simplest form and find any restrictions. So you remember that step 1 is to completely factor the numerator and the denominator. We see that x plus 7 is a common factor, and this simplifies to x squared over x minus 2. To find the restrictions, the denominator cannot equal 0. We factored, we had already done that, and we find there are 2 restrictions. X cannot equal -7 and x cannot equal 2. Now notice, even though our simplified form does not have the factor of x plus 7, x cannot equal -7 because it was here in its original form. We always go back to the beginning to find our restrictions. For question 6, we factored the numerator and the denominator. We divided out the common factor of x plus 1. Our fraction, our rational expression in simplified form is x minus 3 over x plus 3. To find the restrictions, the denominator cannot equal 0, And again, we factored and found that x cannot equal -3 or -1.